Now we're rolling. Yep. All right. Thank you.
You're welcome.
Yeah. Have you ever noticed, Yolanda, like you said, you told me you were more comfortable with this, like you were learning it. You ever notice, like, the words that are used to say how to do something or explain it, they don't change, but your understanding of them does?
Yes.
That's weird, right?
Yes.
It's like you don't get it, you don't know what the words mean, not really, and then all of a sudden, like, oh. Jackie, it's like kind of like looking at one of those pictures that's like blurry, where there's really something there, but you don't recognize it until you just, do you know?
Yeah.
Like a lot of times, like it'll say the word Jesus, it'll say the name Jesus on it, and it's all blurry, and then but once you see it, you can't not see it.
Yeah.
That's kind of how it is with learning math. Like you don't get it, you don't get it, you don't get it. All of a sudden, you get it. And the only thing that changed was between your ears. The words didn't change, the ideas didn't change, the numbers didn't change, just your understanding. Yep. Okay. Ernesto, I got one last thing for you before we begin. You ready? I want you guys to pay attention to what you do when you get confused. See what you do, Evelyn. Watch yourself. See what you do when you get like confused with math. Uh-huh. You stop and then you probably start doing something else, right?
Yep.
That is called avoidance. We don't like being confused. It makes us uncomfortable. And so we try to do something else that makes us more comfortable. But the only way to go from right to right, the only way to go from where you are to understanding the math, the only way is you have to go through the confusion. Confusion is in the middle. There's no way around it. You will never get it if you don't work through your confusion. Yep. It's a true story, Ernesto. Promise. Sometimes if you're really, really, really getting confused and you're really getting frustrated, then sometimes some distraction is good. Like, say you're working at home and you're frustrated and like you're just getting tired and you're just getting like, you feel your emotional level of anxiety just escalating and just escalating and escalating. That might be a good time to take a break. If you feel like punching the baby or breaking your computer, maybe you should step back. Take a walk, take a deep breath, watch some TV, listen to some Beartooth, then come back. But the thing you got to understand, the whole reason I wanted to mention this is you cannot get from what you are now to I understand this new math without going through the confusion. Yep. True story. True story. Okay. Who's got questions on the stuff from last week, from Thursday?
Homework?
Yeah. Ernesto's got a question. Ernesto, this is why you're my favorite student. You always have a question.
Actually,
Oh my goodness. And your stock is going up and up. What's your question?
I couldn't really understand the number 33 or 34.
33 and 34. So check this out. 33 says the square root of 54 divided by the square root of 6. Is that right? Did I write it right? Okay. You know how like we could take something like the square root of 8 and you know how we could break it apart? Do you know what I mean? We can break it apart like that. You can do the same thing here. This is the same as man. What is 54 divided by 6? Isn't that 9? Jackie, is that 9? 54 divided by 6. Oh my gosh. 6, 12, 18, 24, 30, 36, 42, 48, 54. Oh my gosh, that's 1, 2, 3, 4, 5, 6, 7, 8, 9. It is 9. Oh man. I hope you don't have to do that every time, Jacobo. That'd be horrible, right? Yeah. So the square root of 9 is 3. What do you think, Ernesto? Math and magic?
It's a lot easier.
Yeah. Now, let's say you didn't realize that, or you didn't figure that out, right? There's another way to get the answer that's a little trickier, but you can still get it another way. So what we're going to do, now you know 6 is 2 times 3, right? And that means you can't simplify it. 6 doesn't have a factor that's a perfect square, but 54 does. Washa. Check this out. 54, we said, was 9 times 6. Is that right? That true? So I just took that 54 and I broke it apart into 9 times 6, because 9 times 6 is 54. And the reason I use 9 is because 9 is a perfect square. Yeah? Now, the square root of 9 is 3. And then here's what I've got left. I got the square root of 6 divided by the square root of 6. Isn't that 1? So a number, this is just a number, Evelyn, divided by itself. A number divided by itself is 1, so I'm just left with 3 times 1, which is just 3. Yep. We're missing Oscar, huh? But that's the only person? Yeah. You miss him? So no? Not really? Okay. That's okay. All right, Evelyn. And then, let's see, 34 is the same way, right? So, Ernesto, the 34, I think it's 75, right? Over 3. So you want to see, hopefully that can be reduced, 3 into 75. And hopefully it can be reduced, and then what you're left with is a perfect square. That's 25, right? Yeah, so this is the square root of 25. And the square root of 25 is 5. Yep. Right, Marlene? Yeah. So let me ask you guys a question. Let's see how you guys do. You ready? I'm gonna put one of these problems. We've been talking about them a little bit, but I think it's time to practice. And the thing that you have to avoid doing is you have to avoid avoiding. So you have to avoid avoiding. So I'm gonna put a problem up here, and if you're confused, perfect. That means you're about to learn. Right. Let's do. We won't even make it a super tricky one. We'll make it one that's like pretty okay. Oh yeah, here we go. You ready?
Yeah.
You sure? Are you sure? 500. I promise it's not tricky. If you're making it tricky, then you're not thinking about it really very carefully. Not a perfect square. Not a perfect square. You have to look for the biggest perfect square that's a factor of 500. So one number times another number. And one of those is a perfect square, which means it's on your list, which I lost my list. Well, so give it a shot. Give it a shot. The timer right there says 8:50 about, so we'll try till 9:30. She just set you straight?
Huh?
She just set you straight?
Yeah.
Uh-oh. You get it, Marlene?
Yeah, but you go like this. No, porque es como este. ¿Te puedes hacer?
Hey, Gabby. Is your favorite perfect square the number 100? No? Oh, what's your favorite perfect square?
I don't have one.
Oh, that's a problem. So you know what my favorite perfect square is? Is 729. Yeah, that's 27 squared. Yeah. 3 to the 5th power. That's, yeah, let me see here. 27 squared. That's, I think it's 729. Yeah. Anyway, the reason I asked you about 100 is because 100 is a factor of 500, right? 500 times, or 100 times 5 is 500, right? This is 100 times 5. And 100 is a perfect square. That's just 10. Did you get it right, Jackie?
No.
Oh, what happened, Jackie?
I didn't do it.
Jackie.
I know.
Jackie, hold on. Jackie, Mira. If you're not willing to work through the confusion, you're going to be stuck. Hi, Jackie. You are stuck.
Yeah. It's
Yep.
hard.
Did you get it, Yolanda?
I did.
The roof is not my son, but I will raise it, right? No. Whoa. Is she running away?
No, she's just getting coffee.
Getting coffee.
Yes.
Is that avoiding?
Yes.
Big time. That's probably not a very smart move, huh? Okay. Well. Okay. Yes. What other questions do you guys have from last week? Any, Jacobo? Any questions?
I do.
What's your question, Yolanda?
Number 54.
54. That's 9 times 6. Oh yeah, that's ugly, huh?
Yeah, very ugly.
Yeah, let's talk about 54. A word of advice to you guys is, oh, she had it delivered.
Yep.
Why didn't they bring it up here?
That's what I know.
Oh. So, a word of advice. When you're taking notes in math class, if you just write down the numbers that you see without understanding, you're never going to understand. That's not going to help you. Because if just copying what I write down would help you learn, then you could just copy down everything in the book, and then you'd know it all. Evelyn, does that make sense to you?
Yes.
Like, if just taking notes was good, if just writing down notes without understanding was effective, then you could just copy the whole book cover to cover, and then you would know everything. But like we said earlier, sometimes it works like this, like you don't understand, and then all of a sudden you do, but nothing changed, except for what was in here, because you were having to struggle with it and think. You had to work through the confusion. Okay. I have a silly question for you, Jacobo.
Yeah.
Is this a math problem?
Yeah.
Yeah. Math problems are set up so that they turn out to be easy. So even though this looks really tricky and really ugly, it's probably going to work out to be pretty easy. So let's take a look. Like, here's what's happening. Marlene, we have a number times a number, and then minus another number times another number. It's a fraction times a square root. So I have to do, you always have to be careful with PEMDAS, right? You always have to be careful with the order of operations. So what I'm saying is we have to multiply these together before we can subtract. Yeah? Okay. But I can't multiply these together because of the square root. The square root like makes something its own group. Or, actually, it's technically square roots are the same thing as exponents. They're an exponent you don't know about. So we have to simplify first and then multiply. Jackie, what's the biggest perfect square that's a factor of 300? Oh, dang. You go, girlfriend. So can I just do this number as scratch work over here?
Yeah.
So what I'm saying, Yolanda, is I don't want to rewrite the whole problem 17 times because then I'm going to get lost.
Okay.
Like, I'll get confused. So what I want to do, I want to be neat, but I want to do 300 like this. Does that make sense so far? So that's the square root of 100 times the square root of 3. So that's 10 times the square root of 3. So Ernesto, what I'm doing is I took this 300 and I simplified it. So now that I know 300 equals this, I'm going to put it back. Claro? So I have 1/5 times 10 times the square root of 3. We're going to have to reduce that. Fractions are your friend. Yep. All right. Now the square root of 27 we have to take care of also. Square root of 27, well, that's 9 times 3, so that's 3. Square root of 9 is just 3, right? Yolanda, you see what I'm going to do? You see I'm saying right here that the square root of 27 is the same as this. So what I'm going to do is I'm going to take that number and I'm going to write it right here instead. So everything else is going to be the same. Minus 2 over 3 times 3 times the square root of 3. Questions so far? No? Yes, Marlene? No? Okay, Marlene. All right, Marlene, we have to reduce. You want to reduce before you multiply. Look, 1/5 times 10. You put the 10 over 1, right? That's 2. This is 2. 1/5 times 10 is 2. So I have 2 root 3. 1/5 times 10 is 2. Because you put a 1 under the 10, 10 over 5. And so that's asking 5 times what is 10, and that's equal to 2. 5 times 2 is 10. We're going too fast, Evelyn? We're doing fantastic?
Yeah.
Okay. Check this out over here. 2/3 times 3. 2/3 times 3 is 2. 2/3 times 3. It's equal to 2. Because you can put a 1 under the whole number and reduce like that, and it's 2 times 1, which is 2. Also, check this out. Daniela, how many lines do I have right here? It's a pretty tough question, right? If I had 2 out of the 3, 2/3 of 3, how much is left? There's 1 left over, and you have 2. Sorry, I pointed the wrong thing. 2/3 of 3. There's 3. I have 2 out of the 3. Yeah, 2. I don't know if that made sense or not. Gabby's like, what are you talking about?
So it is 0.
Oh, subtraction. That's a number minus itself. Yep. How do you say big 0 in Spanish, Ernesto? No, not me either. I don't speak Spanish. No idea. Okay. Eileen, where's everybody else's coffee? Okay, Eileen. Evelyn's going to remember that. She looks like she's a sweet kid. Better watch out. She's going to cut you.
She works at Starbucks, so she doesn't.
She what?
She doesn't need me to give her. That would be assuming.
Hmm.
It is true.
Wow.
It is true. No.
So, Yolanda, ugly problem, but you see it worked out easy. They're always going to work out easy. More than likely, since there's only 2 things, they're probably going to be able to be simplified and be the same. And they were. They're both square roots of 3. Yeah. So, and then, yeah, fraction. There's a lot of stuff to mess up on this one. Yeah. You have another question, Yolanda?
Many.
She's like, do I?
Well, see what, I don't know, I just started, I don't know, my problems were not looking at all like that, but
Yeah.
now I get it.
Well, like with experience, it just looks neater, and you kind of know what not to do, and yeah, and how to go about simplifying it. Yeah. I'm worried about Jackie because Jackie didn't do any of the problems, did she? Hi, Jackie. Yes, sir.
Can we do the 40 day? Work on 40?
Would it make you happy? Okay, let's do it then. Sky's the limit for you, Ernesto. 49? Ooh, I can't do that one. The square root of 50 minus the square root of 18. Is that right? Okay. They're not the same number, so we can't subtract them. They're not the same term, so we can't subtract them. That's like saying what is A minus B. They're different. You can't. But 50 can be simplified. The square root of 50 can be simplified. And the square root of 18 can be simplified. So what we have to do is we have to simplify those, and then maybe they're going to be like terms. So to simplify them, again, this one's saying like what number times itself is 50, and I don't know the answer to that. 50 is not on my list. So what we want to do is we want to see if there's a part of 50 that is on the list. So 1 and 50, 2 and 25, that's the biggest perfect square. The next is 5 and 10. So we're going to use those two numbers because that number is on our list of perfect squares. So I'm going to go ahead and rewrite it. Then I'm going to do the same thing for the 18. You see, maybe Gabby knows what number times itself is 18, but I don't. I don't have a clue. So I'm going to take that 18 and I'm going to break it apart and see if I can find one of the perfect squares, and I have one right there. 9 is a perfect square. So this is square root of 9 times square root of 2. See how this, if I was doing this problem, if I was you and I was doing this problem and I got this far, I would feel very confident because you see the square roots of 2? They're the same. Probably on the right track. That's 5, right? That's 3. 5 minus 3? You got it right, Jacobo? Increíble. Yeah. You're killing it. You know why you're killing it? Because you're not avoiding confusion. Right, Jackie?
That's what I used to do in the first time.
Mm-hmm. Yep. Yep, you gotta just be okay with being confused.
Yeah.
Even though it makes you feel bad. It makes you feel uncomfortable. At the very least, being confused makes us feel uncomfortable. Sometimes it makes us feel stupid. That's a problem. We should feel very comfortable being stupid because everybody is stupid. Everybody is dumb. Everybody. Think of the smartest person you know, Gabby. Think of the smartest person you know. That person has done a lot of dumb things. Guaranteed.
You think so?
I know so. Who is the smartest person you can think of? You don't have to say if it makes you uncomfortable.
I want to say Gabe.
Gabe? You don't think Gabe's ever done anything dumb?
I don't know.
You don't know. Why don't you ask him? Ask him.
Huh?
Why don't you ask him next time you see him?
I will.
Say, in class we were talking about how math, when we're confused, makes us feel dumb, and we don't like that. The truth is, everybody's dumb sometimes. Everybody does dumb things. Yep. Okay. You ever seen the movie Forrest Gump? No? Whoa. Do you have electricity in your cave? No? Oh, okay. Okay. Wow. You've seen more Forrest Gump, right, Marlene? Seriously?
Wow.
What? Have you?
Yeah.
Oh. Have you? Really? Should they see it? Yeah, it's pretty good.
Tom Hanks?
Yeah. Oh. Well, in the movie, I'm not going to give the movie away. There's just something that has to do with this. In the movie, the character, Forrest Gump is his name. It's the guy that Tom Hanks plays. He's retarded. Literally. And, but his mom is saying that even though you've got, basically she's saying, even though you have this disability, you still have to do the best you can with things. And the way she says it is she says, stupid is as stupid does. That's the saying. And the saying actually came from the Lord of the Rings book, which is weird, a long time ago. Anyway, what it means, Jackie, it means you're smart when you do smart things. You're dumb when you do dumb things. Yep, that's what it means. You're smart when you do something smart. You're dumb when you do something dumb, and that's all there is to it. Doesn't matter what's up here. It's what you do with it that matters. Nobody cares about what you could do, not even your mom. Yolanda, you have young kids, right?
Mm-hmm.
Are they, they're old enough to be able to do a job? Like, say, pick up your toys or something?
Yes.
And you know they can.
Yes.
Right. But you don't care that they can. You only care if they do. If you say to your son, pick up your toys, you're not satisfied with knowing that he has the ability to do it.
Right.
You only care if he does it.
Mm-hmm.
Right. It's what we do. That's all that matters. Not what we could do. Whoa. Okay, Eileen. Yeah, let's do one more. You have one more up your sleeve, right?
I think I'm good.
Really? Oh, sweet. Do you have one you want to talk about? Or you want to move on to what's today?
Let's do like a dividing one.
Oh, this one makes me nervous. Okay. Let's pick one out of the book. Let's do the square root of 150 divided by the square root of 3. Why don't you try? Why don't you try? I would suggest working together. You know one reason why it's really good to work together, Evelyn?
What?
It's harder to avoid in groups.
You have to work together.
That's right, because if you're like wanting to work with Eileen and Eileen just wants to check her phone, it's really rude. It's really rude, and we have a social obligation to the people we're with, and we don't want to be rude like that. The only times it's a problem is when you're both interested in avoiding, and then you're going to talk about something else. You know? That's why it's a good idea to work with somebody. Yolanda, who's older? Wait, do you have a son and a daughter, or two sons?
Boys.
Both boys.
Yes.
Which one's older, the 6-year-old who had his birthday?
I have a 10-year-old.
Oh, a 10-year-old.
Yeah.
Okay. Oh yeah, so he's very much old enough to do stuff.
Yes.
Yeah.
Although they pretend that they don't know that.
So I've never met your son, and I hope you're not offended, but 10-year-olds are dumb.
Well, yeah. Yeah,
They are.
both
Boys,
right.
10-year-old boys. Because they start getting all the prepubescent hormones,
Uh-huh.
and it makes them stupid. It does. At 10-year-old boys are like sub-animal. That's when they start setting stuff on fire. Yeah. 10-year-old boys are a handful.
Yes.
They are.
They both are together, yes.
Yeah. That's okay though.
Ooh, you said so you
Yeah.
do like this.
Having boys or girls, they both have their drawbacks.
Uh-huh.
And
Right.
yeah. 10's probably the worst age.
Mm.
Yeah.
Oh, I can totally picture it in
Mhm.
high school. It's the same thing, just bigger.
They're a little older, but actually in high school in high school it's different. Yeah. They're a little different. Yeah.
They got girls on their mind.
They do, and you have things you can hold over their head a little more. Mhm.
Okay.
Yeah.
Fun jets are girls?
Yep.
How's that like?
Good. Mhm. Oh, you just gotta beat them when they're young, and then, you know. Yeah. Vanessa, did you get this one? No? Let me ask you a question. Do you realize you have to divide 3 into 150?
Like the one we worked on?
Yeah, so you have to see if 3 goes into 150. Well, if it wouldn't, there would be other stuff that you'd have to do that we're not going to learn. Yeah, so for us right now, if it couldn't, you would see if you could simplify the 150 and then see what happens. But other than that, there's other stuff it's called, rationalizing the denominator and stuff. Did you get it, Jackie? Hi, Jackie. Are you avoiding it, Jackie?
I was listening to what you were telling her because I don't know what to do.
Yeah, this.
Uh-huh.
Okay.
Porque this turns into 25.
I don't even know where to start.
I just told you where to start. See if 3 goes into 150. You got it?
I got that part.
Ernesto?
Yeah.
But
Yeah, don't say it.
Wait, let me ask you if I can do
I
it.
got that part. What else to do? That's what I do.
Then you divide it and you reduce it. Did you get
I
it?
have a question. I got it this way.
Okay. Yeah, that's fine
Does
too.
that work also?
Well, wait a minute. Let's see. Where does the 6 come from?
Because I
Oh,
did
6
it,
times 25.
Yeah,
Ah.
because I did it 150.
Yeah, that's fine.
But
Yeah,
then I
that works fine.
realized-
That's fine. I see what you're doing now. Yeah.
Yeah. Oh, okay.
Yeah, that works. Did you get it, Yolanda?
You think so?
You think so? I think you got it too.
It's because I did it harder than this.
But that's fine. That works.
Yeah.
Yeah, absolutely. Ernesto, what'd you get?
Don't laugh if it's wrong. Did I get it? I got 50.
50? Square root of 50? Or 50?
Oh, I just put forgot the square root.
Ah, square root of 50. So you want to know how you can tell if you're done or not?
No.
Look at that number. And if it has a perfect square that's a factor, you're not done. So you need to look at that 50 and see if it has a perfect square. If it doesn't have a perfect square, you're done. If it does have one, you got more work. Did you get that, or did you get something else, Yolanda?
I got something else, I simplified it.
But so you did get this along the way, though.
Mm-hmm. Yes.
That's what he got too. What about Daniela? Did she get that?
Yeah, she got it.
Did she get it the same way you got it, or the
No,
easier way?
She told me the easier way.
Yeah.
So then she
3 goes into 150 50 times.
Yeah.
And then that one, yeah. That's okay though.
Is it 5?
5, and then the square root of 2. It's 50, right? 50 is 25 times 2. And yeah, there you go. So you're doing good. You know what? Okay. We're not having a test anytime soon, Eileen, but I want you to be thinking about how you get credit on tests. What will really wreck your grade is if you leave problems blank. Or if you just write down total nonsense, you're like, okay, he told me I can't leave it blank, and you just write down some total random stuff, right? That's just as good as blank. That's what's going to wreck your grade. If you can actually pass a test and miss every single problem, if you know how to do them, and you can show me like let's say you were doing this problem right here, right? And let's say you did, okay, that's the square root of 50, and let's say you left your answer like that. Well, you're still going to get partial credit. This one you may only get half of the credit, but you're still getting partial credit. And let's say it was a problem that had like 3 steps, like this one. Like, let's say we did one like this. And so let's say you did this step and this step, right? And then somehow or another, you got this, and let's say you just subtracted wrong and you had, I don't know, something silly. Just, made a silly mistake. This problem right here actually might be worth 4 points, and you might get 3 out of the 4. And so by knowing how to do the problems, that's how you're going to pass a test. You won't get an A, but you'll pass. What kills grades is when it's all blank. Like if there's a topic and you leave that whole topic blank, you're going to fail the test. And yeah, okay. All right. Here's what we're going to do today. You ready? Oh boy. Exponents. Are you excited?
Yes.
I think they're easier than square roots.
Good.
Yeah.
That's good.
Yeah. Jacobo, do you remember what exponents are?
Yeah, it's the number times itself.
Mm-hmm. It is, you're right, it's repeated multiplication. We're going to go old school here, Jackie. You ready? Like something you learned in your old school. Ready, Jackie? Okay, Jackie. Jackie, that means, right here, this is multiplication, right? This is multiplication. Right? And what it means is, it means repeated addition. Multiplication means a repeated addition. Okay, so this thing right here actually means 3 plus 3 plus 3 plus 3 plus 3. This will tie into being able to read exponents in just a minute. So do you see that this is the number being repeatedly added, right? That many times. Yeah? Okay. Now, exponents are written almost the same way. The first number is going to be the number being multiplied by itself. The second number is going to tell you how many times. The only difference is it's written in what's called a superscript. It's a little tiny number on the top. This is an exponent. This is the base. And so what this means, this would mean 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5 times. Yolanda, do you know what 3 times 3 times 3 times 3 times 3 is? Me either. I have no idea. Actually, I do, but it's ugly. Right? And like I might know that one, but I won't know this one. I won't know what 3 to the 7th is. And the only reason I know this is because I teach math. And so I just know it. Jackie, I don't know what that is. Do you know what number that is? Me either. But it's a big number. Do you like writing big, long numbers? Me either. I would prefer to write something small and easy. Right? So one of the reasons we use exponents is it gives us an easy way to write a really big number. Like this is a really, can we find out what that number is?
Yes.
Let's see. You got a calculator right there?
Yeah.
We want to erase? It's 729 times 9.
6,260.
Yeah. Yeah. 6561. It's not a really giant number, but it's 4 digits, and this is easier to write. And then, like, if this was a bigger base, like, how many of you guys have a calculator with you? Anybody got a calculator? No? On your phone? Yeah, that'll work. Try this. So watch this on your phone. Try this number right here. Let's do
Why did you do 3 to 7?
3 to the power of 7.
Instead of 3 star 5.
It's just a different example.
Um,
Check this out. 9 to the power of 24. See if your calculator will figure out what that is for you. I don't think your calculator can do it. I'm going to see if this calculator can do it. Oh, not calendar. Calculator. 9. Oh my gosh. Oh, here we go. Scientific. 9 to the 24. I am impressed. This calculator on this computer made the number.
Wait, how did you do it?
Whoa.
Well, I did 9, right?
Yeah.
And then you see that button right there?
Oh, okay.
And then you see it's got the little caret is what it's called. For those of you maybe can't see the screen, it's like this.
Oh.
So it says 9 and then caret, that means exponent, and then you write in 24. And then that is, oh my gosh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That's 23 digits long. Your chances of even copying it down correctly, you're probably going to mess it up just copying it. But how easy is that to write? Do you see what I mean? Ernesto, have I made the case of why we use this instead of those other numbers? Right, because that other number is 23 digits long. It's got 23 spaces. So that's ridiculous. But that's really easy to write. So exponents, they are repeated multiplication, and it's another way to write a number. Just like, okay, you don't want to write addition for this, right? You would rather write this. This is easier than writing all that. Well, that's kind of how this works too. Yeah? Okay. Do you know, Evelyn, do you know how, watch Evelyn, If I wanted to write this with an exponent, do you know how I would figure out what the exponent's supposed to be?
Like counting on how many fours you put.
Yep, so easy a caveman could do it, huh?
Yeah.
There's hope for you, Ernesto. All right, 1, 2, 3, 4, 5, 6. I'm sorry. Will you forgive me? Yeah, that's pretty good. That's pretty good. Yeah. All right. Okay. I'm sorry. Kind of. I should be. If I was sorry, I wouldn't do it again. But I'm probably going to. Yep. Okay. So Evelyn said that the way you can figure out what the exponent is you just count how many of the bases there are. And that exponent goes right there. Right? Now, if you're doing math with exponents, you don't need to multiply that out. You can just leave it just like that. You don't need to write out what the whole number is. Kind of defeats the purpose of an exponent. Okay, Jackie. Jackie, there are rules. Well, not rules. There are things that happen with exponents. Check this out. Eileen, what's your favorite exponent? 3? Mine too. Yeah. That's my favorite, is 3. Yep. Gabby, what's your favorite exponent? 5? Mine too. Yeah. Okay, a couple things. Do you see that those are multiplying? Do you see that these both have the same base? You see what I mean? Well, because of that, we can actually put this together in a smaller way. Because would you agree that this is 3 x's all multiplying? Would you agree with that?
Yeah.
And then this one's 5. 1, 2, 3, 4, 5. I'm not very good at math, but I think that 1, 2, 3, 4, 5, 6, 7, I think that's 8. I also think 3 plus 5 is 8. So like, yeah.
So you could, when it's the same base,
Yep.
then you could also add the exponents.
That's exactly right. So like they often give you this rule right here. This is how they write it. Like they say they're rules. They're not even rules. They're just the way it works. Because, well, like Jacobo, however many this number is, right here, this n, however many that is, it's multiplying with that many a's. So you have that many and that many. So you just add them. Yeah, that's where it comes from. Okay. Jackie, what's your favorite exponent? 3? Good. 5? Okay, Jackie. 5?
Yeah.
Okay. Daniela, what's your favorite exponent? 3? Okay, good. Yeah, mine too. Yeah. Check this out. This is ugly. Like the way that people describe this in math is confusing because they say this is a power raised to another power, and that gets confusing to me. Yeah, it's a higher power, and I guess that's a problem if you're an atheist. Yeah, see, a little math joke there. Right. I can't solve exponential equations because I'm an atheist and I don't believe in higher powers. See, that's the joke. Yeah. Right. Okay, Jackie. This 3 is the exponent, and here the base is. What is the base for this whole thing? Let's go back. Remember, the base is the number being multiplied by itself. Here, the base is actually x to the 5th. The base is x to the 5th. So what that means is that there are 3 of the base multiplying together. There are 3 of them. That would be x to the 5th times x to the 5th and one more. Yeah? Okay. How many x's are right here multiplying together that I'm pointing to? 5. There's 5. You only see one, but there's 5 of them. That's what that means. So there are 5 x's right there. Now I don't mean it's 5x. That's different. That would be x plus itself 5 times. I mean there are 5 x's right here. And how many here?
5.
And then here?
5.
That's 5 and 5 and 5. Isn't that 15?
Yes.
Isn't that 3 times 5? 15? Yeah? So the rule, the way that they write the rule, it's not even a rule, it's just the way it works. It's like a property. Like 10-year-old boys are trouble. It's not a rule, it's just the way it is. Right. Like that. Do you see? So what we're going to do for right now is we're going to have some problems where they're going to give you stuff like this and they're going to tell you to just simplify it, which means use one of these rules. Yeah, so you have just one of each base and you put the exponents together. Let me see here. Yeah. Want to try one? Eileen's like, yes, I've been waiting to try an exponent problem all day. Yes. Okay, let's try 3. Okay, we'll try 3. Don't avoid try. It's going to be one of these 2 rules, right? So let's do you want to use numbers or letters?
Numbers.
Okay, great, letters. A to the 5th. I'm sorry, Jackie.
I don't forget.
You don't forgive me?
No.
I did it on purpose, though. You want to know why?
Four.
It doesn't matter what these are if they're
I
the
know.
same.
It just matters top.
That's right. Okay. Ooh, yeah. Let's do that. And then we'll do a bonus problem right here. Oh no, that one's just rude. We're gonna name number 3 Rudy, because it's rude. Yeah. Are you done, Evelyn?
No,
Are you avoiding Evelyn?
no.
Okay. Before the end of the semester, math is going to be Gabby's favorite subject. She's not believing it. She's going to stop working at Ross and be a mathematician. No? Oh. It's going to happen sooner than the end of this class then? Oh. Never. Never. Huh. That's interesting. Gabby, have you ever said never about something that you ended up... Yeah. Yeah. You done, Jackie? All 3 of them?
Yeah.
Jackie, this is why you're my favorite student. Jacobo's got all 3 of them? Yeah? So Daniela, you're older than Jacobo? How much? 3 years. Oh, okay. And is there anybody in your family younger than you, Jacobo?
Yeah, my little brother.
How old is your brother?
18.
Oh, 18?
Yeah.
Okay. And how old are you?
19.
Oh, okay, so yeah, 18, 19. So he was an accident. No, it's true. If they're 3 years apart and the next one's 1, yeah, oops. You should ask your parents if your little brother was an accident. Yeah. Yolanda, which of these? So we got 3 up here, right? Which are you the most confident about?
The first one.
The first one? Now, let's see. We're going to call this rule number 1, and we're going to call this rule number 2. I keep saying rule. They're not even rules. They're just the way it works. Which of these applies to number 1?
Number what?
Number 1 applies to number 1. That's quite a coincidence, isn't it?
It's quite what?
Quite a coincidence.
Right.
Right. It's almost like I was thinking about how to make questions about these problems in order. That's weird. Yeah. So this is a to the 8th. Is that what you got?
Correct.
Okay. You're not as confident about this one, though.
Well, it just makes you think more.
I'm going to write down the wrong answer.
Okay.
The wrong answer. Gabby, this is the wrong answer. But this is the answer that everybody does wrong.
Oh.
Everybody says that. That's wrong. That would be right if it was, M. That would be right if it was this. But that's not what this says. This says m cubed squared. That means there are 2 m cubes multiplying. That makes down to the 6th. You got it, Evelyn. What? Did you hurt her? Did you hurt her?
Too much.
A little bit, yeah. Some exuberance there. That's cool. That's all right. Now she's awake. All right. Ernesto, did you get the last one?
Yeah.
What'd you get?
I probably got it wrong.
Oh, that's okay. We'll just all point and laugh.
I don't want to say it.
No, go ahead. It's all right.
Um,
I mean, look. How bad can it be? I had the letter wrong on this one, okay?
like, I guess it would be. I think it's a way too much high number. When I got it. And 37.
37?
Yeah.
37. So let's find out. You ready? You have to put these together first. They're in the parentheses, right? And so this part doesn't change. Let's see. That's this first rule right here, isn't it? Right? Putting these together is that. So that makes 7. Is that true? Now, order of operations. This is an exponent, and these 2 are multiplying. So you have to do this first. So the m squared stays the same. Now there's 2 and there's 35 more. That makes 37. Dang!
You got it right. Good job.
I had no doubts. Yeah. Did you get it right too? Oh. Do you see how he did it? Did you have, let's see here, 7, 8, 9. Did you have 45?
I did.
Yeah. You know what you did wrong?
Yes, tell me. No, I don't know what I did wrong.
So here's what you did wrong. This is multiplying with this, right?
Yes.
But this second one right here, this part right here has an exponent. And in the order of operations, exponents, this and this go to first before you can multiply those 2. So it was the order of operations that messed up. Yeah? Okay. Who's got questions so far about any of those 3? Nobody? Okay. You doing all right?
Me?
Mm-hmm. Yeah? Okay. There's a third rule. There's actually a whole bunch. There's 6 that we're going to learn. 6 kind of relationships or properties. Here's the third one. So if you're dividing and the bases are the same, and this is true for all of these, the bases have to be the same, then you subtract. the exponents. The top exponent from the bottom. Sorry, the top exponent minus the bottom. So should I give you like a real quick example of that? Okay. Well, for example, what's your favorite base, Evelyn? 5. Oh wow, that's fancy. 5. Let's say 5 to the power of 7. And then let's say that's divided by 5 to the power of 3. Do you see how this is related to this property right here? You see how all the pieces kind of match? So all you got to do, it's kind of like it's a formula. All you got to do is plug in all the parts where they fit. So you see, A would be 5, right? M would be 7, and N would be 3. So all you got to do is put everything where it fits. And if you can subtract 3 from 7, you got it. That's it. That's it. Easy peasy lemon squeezy. That's it. Yeah. None of the properties on their own, Yolanda, are very confusing. What makes them confusing is that you have to do several at once, like this, like that last one. That's what makes it confusing. Yeah. Okay. Yolanda, when I was 10, my mother was seeing a counselor to help her deal with me. She had been seeing this counselor for years. And the counselor told her that she needed to repair her relationship with me. And so the counselor told her that the way that she should repair the relationship is to think of one thing that she really liked about me and give me a sincere compliment. My mother told me the story when I was like 20 or something.
Wow.
The thing, so she said it took her months to figure it out. The one thing that I did that she really liked took her a long time. And she said, well, what it was is she was proud of the way I got myself out of bed in the morning. That was it. For months, that's the only thing she could think of, Jackie. Yeah. Pretty bad, huh? Tortured my poor mother. But you know what's weird is that helped. I remember when she told me that, and then things got better for her. Well, and yeah. True story, Jackie.
Yeah, it's tough.
Yeah.
I don't know how long it would take me to find one.
Like, what do I like about my son? I mean, I love my son. He's my son, but oh my God, what's wrong with that
You
kid?
have to think about it, yeah.
Yeah, especially for a 10-year-old,
Yes.
because 10-year-olds are developing.
Yeah.
Yeah. I like the way you can burn stuff. Yeah. I like the way you punch your brother. Right. Right. Yeah. Okay. Ernesto, do you have brothers and sisters?
One sister.
One sister. Older or younger?
Older.
How much older? 4 years older? Okay. Do you get along with your sister?
Yeah.
Yeah? That's cool. Does she still live here?
Yeah. For right now.
For right now? Okay. Let's try these. You ready? Let's try a couple. Simplify. This is going to be the last thing we learn for today. Oh my goodness. This one's going to be kind of ugly. Some of these will. We'll start off easy. Let's do x to the 5th times x to the 10th. Oh, here, I got an idea. Man. It's scary. When I get ideas, people get hurt. So, let's watch out. Ah. Huh. Let's try those three. Jacobo, which one do you like better? The square roots or the exponents?
Kind of the exponents.
Yeah.
Yeah.
The rules are easier to follow, right?
Yeah.
Yeah. Which is weird because there's really only one rule for square roots, and there's a bunch for exponents, but yeah.
Yeah, this one has more rules though.
Yeah. Whoa, why are you throwing stuff, Daniela? You don't know? Okay. And Jackie has two brothers?
Yeah.
Older and younger? Yeah. How old is the younger one?
11.
Okay. So you guys are all spread out, huh?
Yeah. Well,
Yeah.
my sister, she's 29.
Oh, you
My
have a
brother-
sister too?
Yeah.
I didn't know that. I did know, but I forgot.
We're 10 years apart, exactly.
Yeah.
And then my brother and I are 8 years apart.
Bobby?
Yeah.
Yeah.
And then it's me that's right now. I was the only one planned.
Oh, that's what they told you?
Yeah.
I'm sure they didn't say that to the other three, did they?
No, they told them in their face.
Oh,
They
wow.
were accidents. I was the only one.
So you're the only planned one, so you're the precious one.
Yeah. And my little brother was the big fool. So.
He's the change of life baby.
Yeah.
Yeah. Gotcha. Hi.
Honey, do you have any keys?
No. Well, no, not that opens any. Why? What's the matter?
It's locked.
Yours is locked? Uh-oh. I don't. What about the other one? Good?
No, hombre. ¿Es en la escuela? Sí. No, estoy en la escuela. Ya salí. ¿El examen? ¿Sí? ¿Cómo está? Yo le... Ok, sí, yo le marco. Es que está bien, we were at the house and went to go pick it up, so I don't know what wash the car.
At the house. And what was it?
I was just gonna tell him to stay.
To what?
To stay at the house.
There's no complicated part of it.
En la casa.
I'm not
No, es que es que me puse Bueno, es en la escuela, güey. No, güey. Very good.
Okay, sorry about that, guys. Marlene, did you get off? Which of these three, Marlene, are you the most confident about?
I don't know.
What? Wait, not even number one? You stop that. That sounds like, come on. You're not giving yourself a chance.
Sí, ¿dónde está mi mamá?
You gotta be confident on number one. That's X to the 15. Yeah. Marlene, do you see how I made these three problems all connected? Well, check this out. Here's what I did. I did this on purpose. Here was my idea. I have to get you guys able to do things like this. And I think if I just gave you a problem like this, you would go, So what I did is I broke it apart into what you do first, what you do second, and then putting it all together. Because do you see, this is x to the 15, right? And do you see that that's this? Right? You see what I mean? So then that means that this part is x to the 15th. And the bottom part is still x to the 3rd. Okay. Am I going too fast? Gabby, you see what happened so far? So all I did is that's number one. And so I just wrote what number one equals. Okay, now we have to use this rule right here. You see? So 15 minus 3. 12. Okay? Do you see how this is this? You see what I mean? So then that means x to the 12th squared, which would be x to the 24. Did you get it right, Jacobo? Yeah.
I noticed that, so I just wrote
You got that?
I did.
See? Do you see how I put it all together?
I stopped at x12 squared. I didn't do the
Oh, yeah.
multiplication.
Yeah.
Okay.
Yeah. But yeah, so yeah, you're done when you have one exponent.
Okay.
Yeah. So here we have 2 with the same base, so you want to put those 2 together.
Mm-hmm.
Yeah. Marlene, when you see an ugly problem like this, what you do is you just break it apart. You just put things together, and you just work your way through it. So what I did is I started with a really simple problem, and then I kept adding stuff to it until I got to something that was a level of complexity that's in your textbook. Because that's the kind of problems that are in your book. Okay, Ernesto, you look super excited. Ernesto, you know what our first quiz is? You're right, a week from today. Our first quiz is a week from today. Marlene's like, yes, finally. Finally. Marlene, how long have you been out of school?
Out of school?
Yeah. When's the last time you took a math test?
Sophomore year?
So it's been a while.
10 years ago?
Yeah. So you're like, yes, finally another math test. What I'm going to give you today, they're like practice problems for the quiz. They're not a quiz. It says group quiz on the top, but that's not what it is. It's just practice problems. So we've done quizzes in the past, and these are old quizzes from years of classes we did before. Okay, so there are. I'm going to give you the one with the exponents first. And the answers are on the back of this one. This one has the answers on the back. You see, Jackie? Jackie, you want to pass these out for me? Yeah. Would you please? So we've got, well, there'll be 1 or 2 extras because not everybody's here. And then there's another. So Jackie's going to give you the one with the exponents. There's another that's got fractions. That one does not have the answers on it. Oh, and you know why we're doing these, right? Because we are not having class Thursday, right? So instead of doing homework, you take one past the other, and then you get used to those guys back there. 1, 2, 3, 4. So instead of showing up in class on Thursday, you should do this during that time. Except for you, Yolanda, because you'll be working.
I know. That means I automatically get a new bonus.
Yeah.
Right?
Sure. Of course. How many you want?
You have 3?
Yeah, there's 3 of them.
There's 3.
3, 4, and 6.
Hey Marlene, when you're looking at these, take one pass the rest down. When you look at these, the ones you want to skip, like when you look at a problem and if you're like, oh, I want to skip that one, that's on the test. It's just Murphy's Law. Like it's absolutely that's the one on the test. Don't skip the ones you want to skip. Skip the ones you want to try because those aren't on the test. Those are easy. Okay. Questions? No? So I will see you guys in a week from today. All right.
The exam is going to be on the Thursday?
Next Thursday, yes. First test. It's a quiz. Right. Yep. So next Thursday. Vaya con Dios.
Okay, thank you. Good night.
See you later, Yolanda.
Bye.
That's true, you see her every day.
Yeah, she works at the high school.
Does that feel weird having your coworkers every day?
No. Because I'm just here to help people. So no, it's not weird. If I was here to be a jerk and make people feel bad and try to make people fail, then I would feel bad, yeah. But no, I'm just here to help people. Even though it doesn't seem like it sometimes, Jackie. Right, Jackie?
Right.
You just think I'm a mamon, I know how you think.
See what
I don't. Why would you say that?
See you later. Because that's what you think I am.
Who said that?
You did.
I did.
You did too.
I did.
Te cuevas.
Right.
I know, I'm teasing you, Jackie. You're a nice kid.
I am.
And even when I yell at you, you're like, okay, I know I deserve that. Right?
Right?
Right.
I actually know when I'm thinking that. I'm sorry.
Bye, con Dios. Doing all right, Ernesto?
I have a couple questions on
Yeah, on what?
7.
What's up? Oh, yeah. Kind of work your way from the inside out.
So inside and then
Yeah. And negative times the negative is positive. And just try your best on that. Don't worry about those too much. You gotta be able to do the others though.
okay.
Yeah.
But in these sorry.
Mm-hmm.
And this just means like 1, right?
Yeah.
And then you would just multiply these 2
Mm-hmm.
and then you would add these.
Yep, so it's 2 and to the 6.
Okay. Wait. And to the 6?
Yeah. 2
2
and 10
and to the 6.
Yeah. Perfect. You got it.
Wait, I don't know. Sorry. When you do,
Oh, those are ugly.
yeah.
Some of those numbers are big.
Wait, but overall, in these, to make it work, I have to find
Common denominator.
common denominator on these.
Yep.
So 10 and 12. So I would have to find
60.
okay.
Yeah.
And then
You can use a calculator to get the denominators and stuff, because I don't want to, you shouldn't spend forever like doing a simple arithmetic. So you can use a calculator to do it, but you got to do them as fractions. Like, I don't know what the common denominator between 60 and 33 is going to be. But you can use a calculator to figure it out and do all the arithmetic. Yeah.
alright.
Yeah?
I'll give it a shot.
Yeah, you'll be alright. I think you're going to get an A against them.
Oh. Hopefully.
Okay, we're doing this on the meeting, I'd be so interested in what we're doing, then
Oh, yeah.
join us.
I left all my stuff over there, so if anything's in the way, you can just move it.
No, I won't touch anything, I'll just, is the PowerPoint thing in here? Oh, I don't know. Huh?
It's weird, that's my best friend's dad, this is his house. He has sugar gliders. Have you looked those up? Little things and they fly. They're animals. Crazy.
Okay. Alrighty. So since we're going to be short on time, we have to be done by 7. I'm not going to go through section 1.3 except to say that it's basically, those are the learning objectives and they're all in your book, but basically it's crime classifications. So a crime is an act or omission prohibited by law. So basically it's either you do something that is prohibited by law or you fail to do something that you're required to do by law. And for a law to be valid, the punishment range must be specified. Well, actually, let me go back. The learning objectives for section 1.3 are basically it's talking about how the government keeps statistics on crime. If you're interested in it, go ahead and read the chapter. I'm not going to test you on it. I'm not particularly interested in how the government keeps all of this statistical information, because depending on which crime bureau you look at, the statistics are different depending on what their focus happens to be. The only thing that I'm really interested in is the Arizona criminal justice system, because it lists all of people's, at ACIC and NCIC, lists all of people's criminal history. So as a prosecutor, as I'm looking at charging somebody, I can make a determination based upon criminal history what their sentencing is likely to be. So those are the only crime bureaus that I bother with. But all that information is in that chapter if it's something that is particularly interesting to you. I was going to talk about it a little bit, but since we're short on time. So crime classification. So this is section 1.4 and 1.5. So as I said, a crime is an act or omission prohibited by law. For a law to be valid, the punishment range must be specified. So for a law to be able to be applied, a defendant or a citizen needs to know what the penalty could be for violating that particular statute. And there's different classifications. There's misdemeanors, and felonies. Misdemeanors are the lowest level offenses. They're things like petty theft, DUI, simple assault, like threatening to hurt somebody, or like giving somebody a black eye, disorderly conduct, yelling, fighting, screaming. They're handled by our justice courts. So those are our lower courts. In Santa Cruz County, our 2 justices of the peace are not lawyers. They're individuals that ran for JP and went to kind of this, I think it's a 4-week judge school. And they hear our misdemeanor offenses. In some counties, like Pima County and Maricopa County, the misdemeanor judges have to be lawyers, but not in Santa Cruz County and not by statute. Misdemeanor sentencing is no more than 6 months in jail or 3 years of supervised probation. So if you were to go to trial on a misdemeanor DUI, they couldn't give you more than 6 months in jail. If you went to trial on an assault case, you couldn't get more than 6 months in jail. For a misdemeanor offense, you go to jail instead of prison. And the difference between a jail and a prison is that anybody in a jail has a sentence of less than 1 year. If you get sentenced to more than 1 year, the law requires you to go to prison. Secondarily, jails hold people that are charged with offenses but haven't yet been convicted. So when a person is being housed in the county jail and they haven't been convicted of a crime, the government is required to treat people very differently than convicted prisoners. Like, they need to make sure that they get a certain amount of exercise every day. We need to make sure, it's mostly we cannot use physical force to detain people unless the people are being combative. So, and the reason for that is that they're not convicted of anything. They're just being held in jail for a myriad of reasons, usually because they fail to show up in court if it's on a misdemeanor offense. And then a misdemeanor defendant could be given up to 3 years of supervised probation. Felonies are your more serious crimes. Felonies are held in superior court. They're kidnapping, sexual assault, child abuse, murder, domestic violence, drug offenses. And your felony sentencing ranges can be anywhere from 1 day in jail to the death penalty. So it depends on the seriousness of the crime. And there's 6 classifications of felonies. A class 1 felony, the most serious felony, is murder in the first degree. And that can hold the sentence of death or life in prison, or 25 years to life, meaning you'd have to serve 25 years before you're eligible for parole. All the way down to a class 6 felony, and a class 6 felony would be something like endangerment with a weapon. So if I'm at City Hall in the park and I'm waving around a gun, and people are in the vicinity who could be endangered by that, I can be charged with a class 6 felony, which carries anywhere from 4 months in jail to a year and a half in jail. Well, in prison. 4 months to a year and a half in prison. Usually when you're convicted of a felony offense, you're sent to the state prison, even if your sentence is less than a year. And probation can be anything from 1 day of probation up to lifetime probation. Sex offenders can be placed on lifetime probation. So you could have a sex offender that goes to prison and serves a 15-year sentence and then has what they call a tail of a lifetime probation. That's reserved for people that the criminal justice system has determined are really, really dangerous. Like, it's predominantly sex offenders. Do you have any questions about the crime classification? Okay. Measuring crime. So that's the crime statistics and the statistics collection bureaus that I was talking about. I'll let you read that. Basically, it really is just a way for the government to try and figure out if there's programs maybe that can be utilized, like for drug treatment. If you see that a certain area has like a huge increase in opiate offenses, things like that. So sections 1.4 and 1.5 deal with the criminal justice system. And your learning objectives for those chapters are to define the vocabulary related to criminal case processing, explain the basic legal requirements for a lawful arrest, describe the tasks involved in the booking process, describe the two major types of charging documents, describe the purpose of an initial appearance, the role of the preliminary hearing and the grand jury, and describe tasks involved in an arraignment. So the way anything starts within the criminal justice system is a report to law enforcement. Now, it can either be the law enforcement officer sees something happening. This is probably 2%. 3% of our reports come from law enforcement actually seeing something going on while they're on patrol, to citizen reports. So I'd say that 98% of all the cases that come to us are cases that are reported by a private citizen or by a business. Now, when we're talking about the criminal justice system and we're talking about crimes, all crimes are not reported. There's a number of crimes that are perpetrated that are never reported. The statistics, depending on what you look at, say that 35 to 55% of sexual assaults are never reported. The victim never comes forward and reports it to the police. So the criminal justice system is only involved in those cases that are actually reported. And normally the report starts with law enforcement. Occasionally the report will start somewhere like a school principal. A child might report something that's happening at home to a counselor, to a teacher, to the principal. Once in a while, people will call my office and they'll report that a crime has been committed and they want us to do the investigation. And then I will refer them back to whichever law enforcement agency should cover it. Whether it's the Nogales Police Department, whether it's the Santa Cruz County Sheriff's Office, whether it's CBP, whether it's DPS. If it's reported at a school, if an offense is reported at a school, the school is then going to forward that report to either the Sheriff's Department or the Police Department. So at some point, no matter where the report comes from, the report's going to go to law enforcement. Then the law enforcement agency is going to start an investigation. So they'll go out, they'll take the initial report from the citizen. They'll start looking at evidence if there's evidence there. Like if somebody says, you know, my house was burglarized and their window was broken and a door was unlocked, they may take pictures of the door. They may take fingerprints that they can send out, but they'll start the investigation. One of the things that they may do is an interview in their preliminary investigation with a suspect. And depending on what that person tells them, then they may end up doing an arrest of the person. Or depending on what the victim tells them. So let's say they're out on a burglary and the victim says, you know, when I was pulling into my driveway, I saw 3 kids running out of my driveway and down the street. And then when I got to my house, it had been burglarized. So the officer calls it in. They round up 3 kids 3 blocks over and they bring them back and the victim identifies them and says, well, I know I saw that kid. And one of the kids has jewelry in his pockets that the victim had already reported missing. So then there'll be an arrest. And the person will be taken into custody. And then the officer can make a determination of what they're going to do at that point. Are they going to book them into the jail, or are they going to cite them and release them, or are they going to just refer the case to the county attorney's office? So any one of those three things can happen. Generally, in a misdemeanor offense, there is no arrest. Most of the time in a misdemeanor offense, the officer will give somebody a ticket. It could be for a DUI, it could be for a dog at large, your dog is out running the streets. It could be for disorderly conduct. You're having a fight with your neighbor and another neighbor calls in, and you're given a ticket. So you never come into the jail, you never get booked into the jail. For a felony offense, the officers can make the determination to either arrest you and bring you into jail and book you. And if you're booked into jail, then the officer's going to have you, the jail is going to do fingerprints, they're going to take your 10 fingerprints, and they're going to take a booking photo. And that booking photo is going to become part of your criminal record. And the reason for that, and the reason for taking the fingerprints, is that down the line, in the future, if you continue to commit burglaries or you continue to have criminal contact, we're able to prove that you were the person who was arrested in October of 2016 for burglary. Because we have your fingerprints and we have a booking photo. So the initial investigation could either be an arrest, and that means the officer has to have probable cause to believe a crime was committed. So in my burglary example, a broken window and an unlocked door would be probable cause. The identification of the young man that they bring back to the house would also add to probable cause. So in order to make an arrest, they have to have probable cause. Now it may be that when they start an investigation, they don't necessarily have probable cause to do an arrest. It may be that those 3 kids weren't around the neighborhood. The victim reported it and they weren't around the neighborhood. But 3 days later, they go into a pawn shop and they try and pawn the jewelry. And the police have provided pictures to all the local pawn shops, letting them know what jewelry may be coming in, and they call the police. And then the police pick these kids up, and then they have the victim come down and identify them. So they didn't initially have probable cause to arrest anybody because they didn't know who they were, but now they do. And they finished their preliminary investigation, and now they've gone to their follow-up investigation. So they go out a second time and investigate. And when they try and arrest them, let's say that the kids fight them and they try and get away. And they run down the street and an officer runs after them. And the officer's chunkier than the kids are, and the officers have, the officer's 35 and these kids are 16 or 17, and the officer's having a hard time catching them. Then another officer comes around the corner with his patrol car. Can the officer hit them to stop them? No. Not for that kind of an offense. They can use reasonable force to apprehend. And it's objectively reasonable force, which means a force that a reasonable person would conclude was necessary to effect an arrest. Now, in all these court cases, they talk about what a reasonable person would do, but at the end of the day, it really ends up with what a reasonable judge would determine is a reasonable use of force. So you have to look at what's the offense. Now, if you've got somebody who has just shot into a crowd of 300 people and shot 60 people, and they're running away, and they still have a submachine gun with them that still has rounds in it, and the cops aren't able to catch them, but somebody comes around the corner, it may be reasonable force, or it may be appropriate under those circumstances to hit him and stop him because of the harm that he's capable of causing. Does that make sense? Okay. So once we finish the investigation, now also the case will eventually come to the county attorney's office. We also sometimes send officers out to do investigations. But we'll talk about that with the CA. So you go from arrest to booking. So if somebody's arrested, then they'll get booked into the county jail. And the purpose of booking is to officially record the arrest. They take photographs and fingerprints, like I said. They can also cite and release. There are times, not for a felony you can't cite and release, but there are times when a defendant will be released because law enforcement isn't sure that the defendant, that the county attorney is going to press charges. So sometimes law enforcement sends the report over to the county attorney's office and says, can you review this and make a determination if you're going to charge this person. If at that point we decide to charge somebody, we have two ways of bringing them into court. We can issue a warrant for their arrest, and the cops can go out and arrest them. Or we can send them a summons and say, you need to appear in court on this particular day. But if somebody's been arrested, then they have to have an initial appearance post-arrest. And the initial appearance has to occur within 24 hours. If a person does not get their initial appearance within 24 hours, they have to be released from custody, no matter what crime they committed. So we make sure that we get judges to see people within 24 hours. So usually judges will come in twice a day to see arrestees. And then post-arrest, at the initial appearance, the defendant will plead not guilty. Occasionally you'll get a defendant who pleads guilty if it's some misdemeanor offense and they just want to get out of jail. The judge will appoint counsel if it's a felony offense or if it's a misdemeanor offense where the county attorney is going to ask for jail time or probation time, or if it's a misdemeanor offense where there's mandatory jail time, like DUI. And then they'll have a bond set, or they'll be appointed to pretrial services. And with the bond, what the court's looking at is what is the most appropriate bond to set to ensure that, one, the defendant appears for court, and two, the community is protected from this particular defendant. And so the judge can set the bond at what they think is most appropriate. So then charging. So after the defendant's been had their initial appearance, we have either 48 hours to charge them if they're held in custody, or if they're released from custody, we have whatever time the statute of limitations allows. So for charging, police reports are sent over to the county attorney's office. One of our attorneys reviews those reports. Those reports are reviewed daily. 95% of the charging done in our county is actually done by the county attorney, George Silva. He reads every police report that comes into our office. And sometimes sometimes on specialized cases, like some of the child abuse or sex crimes cases, he won't necessarily do the charging, but he will have reviewed the file. And then the file will either get referred to me or one of the other sex crimes prosecutors. When you review the file, you say, okay, do I have everything I need here to prove this case beyond a reasonable doubt? Now, the police only need probable cause to arrest. So your probable cause is the lowest level of proof that we have in our system. So they just need to be able to say, a crime was committed, and I believe that this person committed the crime. When we look at the offense, we need to be able to say, a crime was committed, and I will be able to prove this case, or I believe I'll be able to prove this case beyond a reasonable doubt in front of a jury or a judge. So now our burden of proof has gone from down here to up here, because reasonable doubt is the highest level of proof we have in our criminal justice system. So do I have enough proof on the original police reports? Most of the time, I'd say 50% of the time we can charge off the original reports. But the other 50% of the time we need follow-up investigation. For instance, it was a drug case, and it was unlawful transportation of a narcotic drug. We need to get that drug tested. Our officers can do field testing, and they get a pretty good idea that yes, this is methamphetamine, yes, this is cocaine, heroin, but those tests are not proof beyond a reasonable doubt in a court. We need to have them drug tested. So our drug labs are just way overcrowded with people. So once we charge somebody, we have to try them within 180 days. So we have basically 6 months to get somebody tried. So what we do is we'll hold that and ask for follow-up investigation. We'll ask for the drug report, because it may take us more than 6 or 9 months to get the drug report. And we have 7 years in order to charge the case. So we're going to need that drug report before we can charge the case. Another instance where we might need follow-up investigation and we might not charge right away is in a sexual assault case, where the defendant's been interviewed and he denies the charges. He says, I don't know this woman, I've never been with this woman, and we've done a sex kit. And now we're waiting for DNA to come back. Well, we need to get the defendant's physical characteristics. So we need to file a petition asking the court to allow us to get his physical characteristics so that we can then do the DNA test. And those tests take a long time. So a lot of times there's follow-up investigation. But let's say that we're able to go to trial. We're able to go forward. So we do our charging. We get our reports. We have all that we need, or our follow-up investigation has come in, and we charge the case. Now we have to now a judge or a grand jury has to make a determination of whether or not my charging decision was accurate. Was I correct? So then we have a preliminary hearing or a grand jury hearing. In Santa Cruz County, we do everything by preliminary hearing. In Pima County and Maricopa County, which are much bigger than we are, they do everything by grand jury, because they have probably 40, 50 cases, maybe 100 cases a week that they present. We have 5 or 6. So That's what we call a probable cause determination. At the preliminary hearing, it's the same, the judge has the same determination as the police had in the investigation. And basically, the state comes in and we put on our evidence of what we believe if we go to trial, the evidence will show. And we can do it through one witness. We don't have to bring in each witness like we do in the trial. And then the judge makes a determination of whether or not there's probable cause to go forward with the charges. And I think we're out of time because it's now 5 to 7. So we're going to leave it off at the arraignment. Do you have any questions about what I buzzed through?
If someone has a warrant for the arrest and they go to court to like turn themselves in, do they automatically get arrested there?
Sometimes they get arrested, and sometimes the judge will just quash the warrant. And like if you miss your traffic ticket, if you didn't go to court for your traffic ticket and you get a warrant, and you go down to court to try and quash that warrant so you don't get stopped at the court coming through, usually the judge will just quash the warrant and give you another hearing date. But if you're on a warrant because you didn't show up for your sentencing after you were convicted, let's say, of unlawful transportation of a drug, and you come into court and turn yourself in, it's likely the judge is going to keep you, because they're going to keep you so that they can sentence you, or at least get more information so they can be sure you're going to show up. So, if you are stopped with a warrant, though, the police officers have to take you in. They don't have the discretion to let you go. So they have to take you in. So, I don't know how to turn it. Oh, I'm almost done, so maybe we can finish it. No, actually, I have a lot to talk about. It's just... Okay, well, thank you. I'm sorry we couldn't finish, but we'll have an opportunity next week. Did you guys have any questions about anything? You're quite quiet. What happened to you this semester, Sammy?
Yeah, I lost.
How did that happen?
I don't know, I just never talked that much, but until now that I know you're back.
All the time last semester.
Yeah, because then you made me talk.
Oh, yeah, right. Well, we'll have to call it down.
need that. But we don't really need it.
Well, I do. The last tools I got, expensive tools, were from my father-in-law, because he used to have a house with a big workshop, and they moved, and they didn't have room. So he gave me a really nice table saw and a really nice miter saw, and some other power tools. But the table saw is the nice one. That's the one I like. That's my favorite one that he has. Well, that I have now. Yeah. Ernesto, you can come in here and soak up some math if you want. All right. Oh, yeah. He's your tocayo.
Yeah, tocayo.
Ernesto, this is Ernesto. That's Ernesto. He's your tocayo.
Really?
Yeah. Let me get everything started, and then we'll get started. Not in a hurry. To go home, maybe. Right.
Gotta go home and work on my kid's science project.
Oh, yeah. I gotcha.
Yeah.
I know how that goes. Let's see here. Let me get this thing started. Celine, how are you?
Tired.
I got some work for tomorrow's
So are you
class.
tired?
Yeah, I'm tired. Always tired. That's the way it goes. Always tired. Wow.
No, me descanso los domingos.
Okay, let's see.
¿Cómo fue el viaje?
¿Este?
No.
Did you watch the Super Bowl?
No, I didn't.
No, did you?
Oh,
Ernest? Oh, yeah. Okay, that's what I thought. All right. Did you care who won, or were you just watching because it was fun, or?
Yeah, I wanted to see the Fates lose.
Yeah, me too.
And plus, I got a really good friend from Philadelphia.
Oh yeah.
So we were rooting for the Eagles.
I always liked Nick Foles, so I was hoping the Eagles.
And well, yeah, Nick Foles. I mean, he played for the U of A. I
Right.
remember I used to watch him play. And
Yeah.
so, I mean, I wanted the Eagles and Nick Foles to win because it would be the first U of A quarterback to win the Super Bowl.
As a quarterback, yeah.
So that's something.
That's true. Yeah. That's very true. So we don't have class Thursday. 'Cause
Oh, yeah.
I won't be here. So before we leave, I'm going to give you some practice stuff. Because next Thursday, we're going to have our first quiz. What would really hurt your grade on a quiz is if you see problems and you don't even know how to start. If you know how to start, then you'll at least earn partial credit and you're going to be okay. So you can't leave things blank. All right, let me grab my. Yeah, everything's a mess. All right. Lee, did you have a nice weekend?
Yeah,
Yeah. What did you do?
Just on Sunday I went to church, and then I went to my grandma's house with my mother.
Okay.
That's it.
That's not so bad.
No.
Okay. Do you guys have any questions about the stuff we did on Thursday, last Thursday? Maybe. You want to try one? Want to talk about one? if there's a problem in particular, could go over it. That's weird. So now you don't have one in particular? Oh, she does, I bet. Alright, there. That's what we- That's two.
I got here 6 with porque es que tiene para el crust. Ajá, y la salen las cosas también con la novia. Tiene carro. Son muy gastantes. Sí. Entonces tienes un
I wonder if I unplugged it on accident when I turned it. Probably.
Te hubiera gustado una sola.